Hi everyone. So today's video lecture I'm doing on my iPad because my smartboard is being difficult again. So if by any chance the audio is weird or we can't hear everything, just let me know. I will try my best to make this work for you, but we'll see what happens. So first I need you to work on the warm-up exercises. The first one says simplify 3 over 4 minus the square root of 5. And the second one says solve the equation 3x squared plus 8 equals 23. Then we'll move on to example 1, solve a quadratic equation. This is really review. This is really something that you should be able to do independently, but I'm going to walk you through it just in case. In order to solve for x, I need to balance my equation and isolate the x. So I'm going to subtract 11 from both sides, and that gives me 2x squared equals negative 48. And then I need to divide by 2. So I get x squared equals negative 24. And then I find the square root of both sides, which is x is equal to the square root of negative 24. I can say, what's the square root of 4 times 6 times negative 1? Now that negative 1 is important, so we'll get back to it. But I have an x equals, pull out the 4, so that's a 2. Pull out the negative 1 as an I, and then square root of 6. So my final answer is x equals 2i times the square root of 6. Now, you might be thinking, what is I? So let's just jot that down right here. I is equal to the square root of negative 1. It is a complex number or an imaginary number. The important thing to remember about I is that I can pull it out of any square root. So anytime I have a negative number under a radical symbol, I'm going to pull out a negative 1, which is the same as an I. I squared is going to equal 1. Right? Because square root of negative 1 times square root of negative 1 would equal, negative 1. So anytime I have an I squared or two i's multiplied by each other, I'm going to be able to pull out a negative 1, which is going to be really helpful. So really, we're looking at complex numbers today so that we can deal with negative numbers in radicals. Example 2 says, write the expression as a complex number in standard form. Standard form of complex numbers just look like this: a plus b times I. So that means I have a constant, and then I'm adding it to a second constant multiplied by my complex number I. So whatever order my equation comes out to, I need to write it in that standard form. Letter A, I'm going to start with 8 minus I plus 5 plus 4I. So I just kind of need to rearrange my terms and add them together. So 8 plus 5 goes together, plus negative I plus 4I. 8 plus 5 I know is 13. And I'm going to add that to, I'm going to remove the I from both sets of, from that quantity there. So if I take out an I have I times negative 1 plus 4, which is the same as 13 plus 3 i's. So if you look, what I did was I removed the I from each quantity inside that parentheses, and I made it like it was almost a distributive property. So I took the I out, and I left my coefficients inside my parentheses, and then I rewrote that in standard form. Letter B is similar. I have 7 minus 3 minus 6i plus 6i. Now my first 6i, I said it was a minus, but the second one I said it was a plus because there's a negative and then there's another negative. So I turn it into a plus sign. And in this case, I'm going to go through. 7 minus 3 is 4 minus, again, I'm going to remove the I from both terms, I times 6 plus 6. So I can continue to simplify, and I have 4 plus 0i, which is the same as just 4. Now, this is a 0 because this negative goes with this first 6, and the second 6 is positive, so a positive 6 and a negative 6 is equal to 0. Last one, letter C. This is a little trickier just because of the signs. So I want to make sure that I'm paying attention. I have 10 minus 6 plus negative 7i plus 4i. And now I wrote the negative because I have this minus over here, so I need to move it into my inner term. Then I can factor out that I again, 10 minus 6 plus I times negative 7 plus 4. 10 minus 6 is 4 plus negative 3i, or just 4 minus 3i. This is going to work for your solution on that one. Moving on to example number 3. It says multiply an expression as a complex number in standard form. So again, I'm going to simplify thinking about I as a variable, and then I'm going to write my solution in standard form. So the first one, I have 4i times negative 6 plus I. I'm going to think of this just as being a distributive property problem. So 4i times negative 6 is negative 24i, plus 4i times I is 4i squared. Now, that's going to be important because we talked about what I squared really represents. So negative 24i plus 4 times negative 1, right? I squared is the same as negative 1. So now I have negative 24i minus 4, and I need to write that in standard form, so I need to write it as negative 4 minus 24i, because my I term should always be in the second term when I'm writing in standard form. Letter B is similar, except I'm going to use my FOIL method to combine these terms. So first term, 9 times negative 4 is negative 36. Outer 9 times positive 7i is plus 63i. My inner terms, negative 2i times negative 4 is positive 8i. And lastly, negative 2i times positive 7i is negative 14i squared. So I'm going to combine my terms and simplify. Negative 36 plus 71i minus 14 times negative 1, and then simplify some more. Negative 36 plus 14 plus 71i is the same as negative 22 plus 71i, and that's in standard form. So we're really thinking of I as a variable. Occasionally an I squared will turn into a negative 1, and then we'll get rid of that altogether. But as we continue, we're really thinking about I as just another variable that we're used to simplifying, and we just move forward from there. Example 4 is a little different because it says write the quotient in standard form, which means I need to do the division, and I need to figure it all out in standard form with the complex number I. So my problem is 7 plus 5i over 1 minus 4i. Now, we can go over this in class more, but I just need you to trust me on this one. The way that I'm going to make this work is I'm going to multiply by 1 plus 4i over 1 plus 4i. Now, the short story is that any number over itself is going to equal 1. So by multiplying by essentially 1, I'm not changing my equation at all. I'm just manipulating the numbers to make them work for me. The other thing you might recognize is that 1 minus 4i times 1 plus 4i is a difference of squares. So when we talk about foiling or factoring quadratics, we look for those difference of squares patterns because they're easy to work with. So you'll see when I multiply out that I'm actually going to be able to cancel some terms in my denominator, and that's why I'm utilizing the difference of squares property. So in order to make this work, I need to FOIL both my numerators and my denominators. So first I'm going to FOIL my numerator. The first terms give me 7. Outer terms give me plus 28i. Inner gives me plus 5i. And last gives me plus 20i squared. And that's all over my denominator. First term is 1. Outer term is 4i, inner term is negative 4i, and last term is negative 16i squared. So if I take that whole fraction and I simplify what I can, I'm going to combine the like terms that are in the middle. So I'll say 7 plus 33i plus 20i squared over 1 minus 16i squared. Then I'm going to use my I squareds and I'm going to change them to negative ones and simplify in that way. So 7 plus 33i minus 20, because 20 times negative 1 is negative 20, over 1 minus 16 times I squared is positive 16. So simplifying further, 13 plus 33i over 17. And that looks like it would be in a standard form. It'd be the simplest way that I can write that problem. But to write in standard form, I actually need two separate terms. So I need to do 13 over 17 plus 33i over 17. And that would be the correct answer in standard form. Example 5 looks complicated, but it is not. It says plot the complex numbers in the same complex plane. So if you think about the coordinate graph that you're used to, and you look at these examples, letter A says 3 minus 2i. So I'm just going 3 spots to the right and negative 2 spots down, and I'm getting to that correct location. So your first number is your real number. That's your x. Your second number is your imaginary. That's your y. So x is still horizontal, y is still vertical, positive is still to the right and up, negative is still to the left and down. So you just need to account for those different things. This last problem, letter D, is off. It should be 4 plus 3i. So that just happens to be in the wrong location on my graph. I'm sorry, negative 4 minus 3i. So it's in the wrong location on the graph, but just so that you keep in mind, by looking at this image here, you should be able to figure out how all of this works. Don't forget your daily homework quiz. You need to solve this expression, 3x squared plus 8 equals 76, and then evaluate the two expressions below if x is equal to 5 minus 8i and y is equal to negative 9 plus 3i.